Okay, so in this vid, we'll talk about probability and odds. We'll start off by talking about an experiment. An experiment is any occurrence in which the outcome is uncertain. So an example of that is flipping a coin. The sample space will be all possible outcomes of an experiment, usually denoted by capital letter S. And in this example, heads and tails would be the sample space of flipping a coin. Now your event is any collection of outcomes in the sample space. So an example of that would be tails. The probability is the likelihood of the occurrence of a particular event. So if we want to know the probability of landing tails, that's where we would go with that. It's always between 0 and 1 inclusive. So that means it's possible to be 0. If the probability is 0, then that means there's no chance of that event occurring. If the probability is 1, then that means there's a 100% chance of the event occurring. Computing probability. If you want to know the probability of your event, you will take the number of outcomes in your event and place it over the number of outcomes in your sample space. So let's say if we go back to flipping a coin, we want to know what's the probability of landing tails. We would look at our sample space. The number of outcomes in our sample space, heads and tails, would just be 2. Always establish your sample space first. That's always the easiest way to look at probability, look at how many total outcomes you have possible. And then our event tails, that's only one event or one outcome in your event. So once you establish both of those numbers, you take the number of outcomes in your event, place it over the number of outcomes in your sample space, and that would be 1/2, which would be a 50% chance of landing heads or tails. All right, so another example, a single die is rolled. Find the probability of rolling a 3. That's the first one they give us. So once again, let's establish our sample space first. Whenever you're looking at a die, we have the options of 1, 2, 3, 4, 5, and 6. So there's 6 possible outcomes that are in your sample space. Then our event is rolling a 3. The number 3 is just one outcome. So we have one outcome in our event, 6 outcomes in our sample space, so that would be 1/6 as our probability. So looking at B, what if we want to know the probability of rolling an even number? Our sample space is going to be still the same. We haven't changed the problem. So our sample space is still 6. There are 3 even numbers in our sample space, 2, 4, and 6. So that would be 3/6. And you are expected to reduce. So 3/6 reduces down to 1/2 as our answer. Then for C, if we wanted to know what's the probability of rolling a number greater than 2? Once again, our sample space is still 6. The numbers that are greater than 2 in our sample space would be 3, 4, 5, and 6. So we have 4 outcomes that are greater than 2. Place the 4/6 and then reduce. That would be 2/3 as our answer. Okay, next example. A fair coin is tossed 3 times. What is the probability that 2 heads and 1 tail are tossed? So once again, establish your sample space first. Here we can create a diagram, use a tree diagram in which we're looking at first rolling or flipping a coin landing heads, then the possibility of landing heads or tails, then for each one of those landing heads or tails. So starting off with heads, notice we have heads, heads, then we have heads, heads, or heads, 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 excuse me, then heads, heads, tails, heads, tails, heads, heads, tails, tails. Then for the second set of scenarios, we started off landing tails first and then branch out. So there'd be tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. So there will be 8 possible outcomes that could occur. So that means the number of my sample space is 8. And then when we look at our event, 2 heads, 1 tail, there are 3 different times that we get 2 heads and 1 tail. It's heads, heads, tails, heads, tails, heads, and tails, heads, heads. So that's the number of that event would be 3. So you place it 3/8, and that is our answer. All right, another example. 2 fair dice are tossed. What is the probability that the sum of the pips on the face of the 2 dice equals to 8? So establish your sample space. We know 1 die has 6 options, 6 outcomes, but we're looking at 2 dice this time. So what we would do is take the number of outcomes in both dice, and multiply them. So that would be 6 times 6. That means I'll have 36 different possible outcomes in our sample space. So just to expand this out, let's say if one of my die had 8 faces or 8 outcomes and one has 6, then it would be 6 times 8. And that would be 48 different ways or 48 different possible outcomes. But we have 6 and 6 in this case. 6 times 6 gives us 36. That's going to be our bottom number. Then our event is that the sum of our faces would be equal to 8. So we have 5 different ways that could occur. Die 1 being 2, die 2 being 6, then 3 and 5, 4 and 4, and die 1 being 5 and die 2 being 3 is different from 3 and 5. So we have 2, 6, 3, 5, 4, 4, 5, 3, and 6 and 2. Those are your different ways that you can add up to give you 8, and that's 5 different ways that our event could occur. So place the 5 over 6, and that would 5 over 36, excuse me, and that would be your answer. All right, almost finished. Calculating odds. So favorable outcome is one that satisfies some event. Unfavorable outcomes would be the opposite of the event. So if you want to calculate the odds of an event, odds in favor of your event would be the number of favorable outcomes over the number of unfavorable outcomes. Then odds against your event would be the number of unfavorable outcomes over the number of favorable outcomes. So let's look at an example that talks about that. So if a pair of fair dice is rolled once, what are the odds in favor of rolling a sum of 7? So go back to our sample space. We already calculated that. That's going to be 36. The number of total possible outcomes is 36. So now my event is that my sum is equal to 7. So how many different ways could you add up to equal 7? 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. So we have 6 possible ways to get 7. So the number of my event is 6. That means there are 6 favorable outcomes out of the sample space. So now if I want to know the number of unfavorable outcomes, I would take the sample space minus my favorable outcomes, and that will give me 30. 36 minus 6 is 30. And so now to calculate the odds in favor, we'll do favorable outcomes over the number of unfavorable outcomes. 6 over 30, reduce that down to 1 over 5, and that's our answer. And so my statement could be made that the odds in favor of rolling the 7 are 1 to 5. All right, if you have any questions, let me know.